In the previous video we have learnt about what makes an equation homogeneous, that is homogeneous differential equations, and how to solve if an equation is homogeneous. So today we are going to solve certain problems. So this is Riyaz teaching you Max 2B. Let's get started. As you can see, the first problem is solve x squared plus y squared dx is equals to 2xy dy. So first of all, let us check whether the equation given is homogeneous differential equation or not. So the question here is x squared plus y squared dx is equals to 2xy dy. So for an equation to be homogeneous, it should be in the form of dy by dx is equals to f of x comma y by g of x comma y. This is the first condition. So let's convert the given equation into this form. So I am sending this dx here down to the dy. Here it is multiplying, here gets divided. So x square plus y square is equals to 2xy dy by dx, right? Then next I am sending this 2xy here. Here it becomes denominator. So dy by dx is equals to x square plus y square by 2xy. So this is the first condition. This equation satisfies and provides us the information that this might be a homogeneous differential equation. For a given equation to be a homogeneous differential equation, this function and this function must be homogeneous, and we know that for a homogeneous function it must satisfy f of kx comma ky is equals to k to the power of alpha f of x comma y. If these two functions satisfies this condition, then the given question is homogeneous differential equation. So let's check whether the given functions are homogeneous functions or not. The first function here is f of x comma y, that is x square plus y square. So I'm just simply replacing it with 2x comma 2y is equals to 2x whole square plus 2y whole square, right? I'm just replacing the value of x by 2x and the value of y by 2y. Wherever you find x, you just replace it with 2x. Wherever you find y, just replace it with 2y. Now moving further, so in simple, this is 4x square and this is 4y square. 4 is in common. X square plus y square. X square plus y square is nothing but f of x comma y. 4 of, I'm writing f of x comma y first, and we can write this 4 as 2 to the power of 2. So f of 2x comma 2y satisfies the condition of homogeneous function because it's in the pattern of f of kx comma ky is equals to k to the power of alpha f of x comma y. So this is the homogeneous function. This is the homogeneous function of degree 2. Let's check the second equation, that is g of x comma y 2xy. So just I'm replacing it same by 2x 2y. So 2x, wherever you find x, just replace it with 2x. Wherever you find y, just replace it with 2y. So you get 2 of 4xy. I am bringing 4 out of the bracket and keeping 2xy into the bracket. So in simple, this 2xy is nothing but g of x comma y, and this 4 can be written as 2 to the power of 2, and this is g2x comma 2y, which means this function also satisfies the condition of homogeneous. So this is also a homogeneous function of degree 2. If you observe keenly, you will notice that the degree of both the equation is 2. That means both the function has the same degree and both the function are homogeneous. Hence the given problem or the given equation is homogeneous. So we can solve the problem using the substitution method, that is y is equals to vx. So we can solve the problem using y is equals to vx. So this is the simple procedure. This is a simple thing. By looking at it, you can understand whether the given equation is homogeneous or not. For better understanding, I have just solved it out to make you clear that this function is homogeneous and we have to use y is equals to vx and solve the problem. So now let's solve the problem using this substitution method. So the differential equation here is dy by dx is equals to x square plus y square by 2xy, right? So wherever you find y, replace it with vx. Why are we doing this? Because this is homogeneous differential equation. This whole thing is homogeneous differential equation. So that's why we are changing y with vx. We are replacing y with vx to solve the problem easily. So wherever find y, I'll just replace it with vx. D by dx of vx is equals to x square as it is plus y. I'm replacing it with vx whole square, and then again in the denominator 2x into vx. Now continue further. If you notice this is in the form of d by dx of uv. What is the formula? Formula is u into derivative of dx, dv by dx plus v into du by dx. So change here, v into dx by dx plus x into dv by dx. Here x square plus v square x square by 2v x square. You know the derivative of dx by dx is 1, so it's 1 plus x dv by dx is equals to, here x square is in common, x square of 1 plus v square by x square of 2v. Cancel x square. What we get here is v plus x dv by dx is equals to 1 plus v square by 2v. The previous step, which is v plus x dv by dx is equals to 1 plus v square by 2v. Now what we are doing is sending this v on the right hand side. Positive becomes negative. X dv by dx is equals to 1 plus v square by 2v minus v. X dv by dx is equals to 1 plus v square. So here we are multiplying this with this because there is no denominator. So by multiplying it, it becomes a common denominator. So minus v into 2v by 2v. X dv by dx is equals to 1 plus v square minus v into 2v minus 2v square by 2v. Now again x dv by dx is equals to 1 plus v square minus 2v square is nothing but minus v square by 2v. Now Now interchanging, taking this x and dx here and v and dv here. So it's in the denominator, it becomes in the numerator 2v, okay, x of dv by dx. We are solving step by step so that you may not get confused. So I'm just increasing the steps, okay. And now sending this dx here, 2v x dv is equals to 1 minus v square dx. Now again we are sending this x here and 1 minus y v square, 1 minus v square here. So what we get, 2v by 1 minus v square dv is equals to dx by x. Got it? Now what we have to do is integrate. Now we are integrating both the sides. 2v by 1 minus v square dv dx by x. Sorry, dx by x. So we know integration of 1 by x dx is nothing but log x plus c. This is the formula you should remember, everyone should remember, so that it would be easy to solve the problem. Next, but what is the formula for 2v minus 1 minus v square dv? Let's break it out. What we have to do here is, I'm just simplifying it so that you can understand easily separately. So look at here, just what we are doing is, we are taking u is equals to, let u is equals to 1 minus v square, okay. Now differentiating both the sides, du is equals to differentiation of d by of constant is 0 and differentiation of 2v is 2v dv. So 2v dv is equals to, I'm sending this minus here, minus du. Now replace here. What? 1 minus v square is u and 2v dv. 2v dv is 1 minus v square is u, 2v dv is minus du, and we know the formula for 1 by u du. I'm sending minus outside, log u minus log u, nothing but minus log of 1 minus v square. So the integration of this step is nothing but minus log 1 minus v square is equals to log x plus c. Alright, this is the rough work. This is the complete rough work. So minus log of 1 minus v square is equals to log x plus c. And everyone should know that log of log x plus log c or log a plus log b is equals to log xc. So the multiplication of both the logarithms gives you the addition. So I'm changing here c as log c, log c as log c, and writing it same, log 1 minus v square. Now this becomes log cx minus log 1 minus v square. Now sending this here becomes positive, log cx plus log of 1 minus v square is equals to 0. 0 can be written as log 1 is nothing but 0. So replacing it with log 1, log x, log cx plus log of 1 minus v square is equals to log 1, nothing but log of cx. This is an addition, nothing but cx is multiplying with 1 minus y square. So cx of 1 minus v square is equals to log 1. Now log cx of 1 minus v square is equals to log 1 log cancel, cx 1 minus v square is equals to 1, cx equals to 1 minus, we know that y is equals to vx, we took it, so what is the value of v? V is equals to y by x, so replace v by y by x whole square is equals to 1, cx of 1 minus y square by x square is equals to 1, cx of x square minus y square by x square is equals to 1. There is no denominator, so directly multiply this, x square minus y square is equals to 1. Now x get cancelled, c of x square minus y square is equals to x. The final answer is this, c of x square minus y square is equals to x. So let's solve next problem.